But Jan represents Signify, and for those of you who haven't quite caught up, Signify is the not so new name for Philips Lighting. So I'd like to right now hand the platform over to you, Jan. Please take it away.
Thanks very much. Yeah, I work for corporate product security within Signify. Like one of the products you might know is the Philips Hue connected lighting. I'm a member of the Many Secured work group, and like Nick already mentioned, I focus on the secure, usable intranet browser. And I'm here to talk about communicating securely in your own home. Nick did a presentation last year when the topic was security by design, secure by design, sorry. And he showed this picture also where he showed his devices, and I noticed that he has a Hue bridge. He also noticed that he mentioned that he has a problem with the security connecting to any of these devices. If it has like a web server for management, he will get a security warning. So a certificate is not valid. And I would like to go into much more detail about that. So if you want to connect to one of those Philips Hue bridges, then you can type philips-hue.local, and that's based on the multicast DNS. So the device advertises its name and your browser can connect to it. You can also connect by its IP address or its IPv6 link scope address. And that one contains the MAC address. But none of these things will be secure. So you can't really like set a secure connection. It will be encrypted, but you get this warning. And that also means that the certificate on these devices can be spoofed. Now, this is the certificate from the Hue bridge. And if you look at the subject, it says that it's the MAC address. So that is the unique bit. The nice thing is that the device itself has a unique certificate, and then it's signed with our root. Our root, unfortunately, is not part of the trust store. So if you connect to it, you get this warning, and it says potential security risk. Attackers might try to steal your credit cards, your passwords, emails, you name it. The thing is that I'm not after your credit card details, at least not if you're not buying our products. This is the warning message you get in Firefox, but you get the same one in Chrome, and you get the same one in Microsoft Edge. We can't really use this for management. We can't explain normal people on the street to go to this really weird URL, click advanced and accept all types of exemptions, and then to do your magic business there. So that's why like we only use it to show you the open source licenses. ETSI standard, we discussed this one last year as well. It's really great. It has 13 rules, and one of them is to communicate securely. So from a standards point of view, it's really important that you communicate securely. If I go into OWASP, they also have like a vulnerability list, and they list that using HTTP clear text is not secure. So you have to use HTTPS. It's just the best practice. So I contacted Nick last year. We focused on the SWIP project. We already published this document called Insecure by Design. And quick summary of that one is that if you don't have a certificate, you don't have encryption on the network. Quick history about certificates. It's in the 80s that ITUT has published this X.500 series. Internet wasn't really a thing back then, and they were creating a directory. Now, focus on X509 and you have a certificate. Netscape used that standard to create SSL. And by the turn of the century, IETF took over the standardization and calls it TLS. TLS 1.3 is the current version. And if you're using something older than 2 generations, so anything before 1.2, you're doing something terribly wrong. 10 years is quite a long time to migrate your stuff. Where does trust come from? It's a bit complicated slide. I will gloss over it very quickly. So Netscape became open sourced, became Mozilla, and they keep their own root CA program. And what they do is they collect all types of root certificates from all the organizations they trust, and they basically put it into a big store. Mozilla Firefox would use that store, and I will show you how it looks like soon. But Windows, Microsoft did exactly the same thing. Google has a root, Apple has a root, Adobe, and tens of others, big organizations that collect all types of root CAs. Now, if you have the browser, like for instance, Firefox, it would use its own root store. Unless you have the mobile version, then it can use the one from the operating system. This is the Firefox certificate trust store. It has a bunch of authorities. I don't necessarily know them all. I don't necessarily trust them all, but this is what you get for trust. This is the version for Windows. So it's the same type of CAs that are listed in here. And that means that if you connect to any of the devices that is signed by one of these root CAs, it is trusted, you get the green padlock, everybody is happy. Now that was Windows, and this is like a command line for OpenSSL. So the Linux would use this type of system. Now, the problem that I have, and that's also what I mentioned to Nick a year ago, is that the organizations they collected, so the browsers and the CA roots, they were collected in the CA browser forum in 2005. And what they do is they set up rules. Like if you do not follow these rules, you're kicked out of the group. You will no longer be trusted. So one of these rules, 71421, is about subject alternative name extension. Now, the certificate is valid for whatever is in the subject or the subject alternative name. And they have this rule, I blurred out the rest because it's not interesting. It is that CAs shall not issue certificates with a SUN extension or the common field that has a reserved IP address or internal name. And I showed you, like for the U-bridge on slide 3, I showed you like that is exactly how you can connect to the system. So technically, we cannot have signed certificates for our system. Now, we have worked around that, and you would say like you can work around the problem. So why do you bother? I want to bring secure connections to the home, and I would like to think holistically to create a technical landscape where you actually have certificates that you know you can trust. Now, this has to be simple and secure because it also has to work for grandma. And if it works for grandma, it will also work for small businesses and factories and any of the other systems that do not have like any of the experts like enterprises do to do the security right. And as a bonus, if you have like the TLS PKI, technically it could complement or replace passwords. So the point of like what I'm trying to achieve is to get a technical landscape so that like the trust is not just for internet banking and for shopping, but also for the devices in your own home. We have in the work group discussed also some solutions. We will publish a paper containing these solutions, but unfortunately, none of these solutions actually fix anything. They are like just partial fixes. They are ingredients, I would call them. Now, the first thing is to do the warning. I already mentioned this credit card. It's an exaggeration. The actual warning message should be that you are visiting a device for which the certificate cannot be verified. Nobody's stealing anything, might be, but I'm not trying to. The other thing is that a browser has the internal plumbing to actually be network aware. Because if I use a browser, it knows its IP address. If I'm connected to the device, it knows that it's also a private IP address. And that means that you can modify the warning message in that situation and to say, this device is located in your own network. Do you want to continue? And I'm not a text writer, so if somebody comes up with a better term to propose, then let's use that. The thing is that the internal and external context matters. Because if you're like connecting to your bank over the internet, that's a different type of context than me trying to connect to my own device, just literally meters away from me. CA browser forum, they make the rules together. Somebody proposes a change and you can vote for that change to happen or not. And the thing is that if we have some clever text, which I unfortunately do not have, we can propose how a .local address can actually be signed and validated. Now, the problem is that you, in your own network, you need to have like something unique, something that can be verified by an external party. And in your network, you do not have that. My network here is 10.0.0.0, and it's very likely that you have a similar type of network. So there's nothing that sticks out. The thing that I find annoying is that for Tor addresses, so .onion, they can get signed certificates. So EV extended validation rules allow for the dark web to have signed certificates because they have something unique. They can be validated externally. So we need some clever text, in which case a .local can be signed. And that means that we have to introduce something unique to the network. Problem with that is that it's also opening up misuse. What if an advertising company or like an attacker will start to fingerprint your network? So we have to also keep that secure. So solution 3 isn't actually fully written. There's a lot of like drawbacks there. You can't fix it. Now, one of my solutions is a local gateway. Nick already showed that you can have all these gateway devices. They can run applications. You can theoretically install a local PKI on it. So if I have like a device that can act as a trust store, then if you have like a method for like easily sign or do a gesture, or you press a button to welcome a device, to onboard a device in your own home, then you can get things done as well. So the question here is, how do you bring uniqueness to your network and prevent misuse? One of the great standards, Michael, this one is to you. Great standard released in August, I believe, is called BRSKI. And the way that this works is, for an enterprise, you buy a device and you plug it into your enterprise network. The device then has to be configured. So instead of like doing manual tasks, what you can do is you can ask whoever sold you the device, you can ask them, did I buy this device? And if the answer is yes, you can join the network, because there's a thing called the IDEF ID, and you can have this certificate from the factory, which can prove that this device is really from that vendor. So if you then ask the vendor, like, did I just buy this device? And the answer is yes, you can join it into your network. And that is basically plug and play for the enterprises. The drawback for the consumer market is that you can't really have like a registry where you keep track of who owns a device because of privacy concerns. So in my view, it would be really great if we can like extend BRSKI in such a way that you can onboard things for consumers. What we can absolutely reuse is like the EEE 802.1.AR, sorry, I got the dot wrong, certificate to bootstrap this trust in your own network. One of the solutions is also to like introduce this device DNS name. One of the examples is what Plex has done, is they created an application. The application is wrapped around something local. So your local device creates a very long URL. And then basically you get a signature, you get a certificate for that long URL. So the actual global application is using local information from the device, and you still get a green padlock because that's a signed certificate by a valid person. Christian Amsus has written this RFC experimental draft where he explains how you can create this key pair, create a common name, so what the device is called, make that into a URL with .devices.vendor.domain name. And based on that, you can like add it to the global DNS server. And what you then can do is you can sign that domain name, because that one you can verify. And then the local device will have a certificate which is valid. Now that way you can actually get a green padlock in your own home. But there's a problem, and that's called the rebind attack. So there's a protection against it in your own network. Because what if malware is trying to attack through JavaScript, for instance, in your own browser? How is it going to attack the gateways that you have? So the browser will basically block this already. Now, if you're like breaking open the whole IoT infrastructure, why don't you take all the bits that work and the bits that don't work in the scope of IoT and build something that creates this global unique domain for the local context and create like a CA authority? Yeah, then you need to have a domain name. So if you figure out which domain name to use, then you can like build this IoT infrastructure. It's basically like a copy or like a next version of the internet. And yeah, this requires quite a lot of effort. So if there's an institute, university, or a government body that's willing to pick up the fight, this would be really useful. And the last one, it's a bit simpler, but still takes more than a Sunday afternoon, is maybe we need to have like a separate browser or an app, which is like generic for all types of IoT devices. So if we have an IoT browser, which can enroll devices and can track it, that will benefit mankind. To wrap it up, we have a triangle. You have a browser. The browser goes to an address, and the address is certified by a certificate. We are stuck in this triangle, and we need to break it in order to bring trust into your own home. Last slide. The context matters. So intranet, so in your own home, is different than internet banking, and therefore, we need to have the code plumbing for this. It's quite simple to change a warning message. It's a one line of code, one line of text, but it's really difficult to attach a meaningful domain name to a device. And it's difficult to validate that a device is really yours. And therefore, it's difficult to establish a trust relationship, although you just bought the device. And this requires working with quite a lot of organizations. Thanks very much.